Okay, ladies and gentlemen, welcome to the Chapter 2, Section 6 video notes. This section in class has been combined with Section 2-5 into a single note packet. So this should start about 7 or 8 slides into the 2526 note packet. We're talking about algebraic proofs in this section, which is basically a way for us to take a skill that everyone is relatively familiar with, that is solving linear equations, and use it to introduce the formal process of geometric proof. Okay, so we first need to go through a number of algebraic properties that exist from your algebra classes, or pre-algebra classes should have covered all of these as well. So everyone should be relatively familiar with each of these 9 ideas. None of them should be new material, but if they are, I'll make sure to explain it in such a way that will still be okay. So the first thing we need to talk about here is we're talking about properties of equality of real numbers. And what that means is A, B, and C are going to be real numbers. So we need to discuss, well, what are real numbers? Real numbers would be any number that you have worked with up through this point. Your rationals, your irrationals, your integers, your counting numbers, your whole numbers, those are all types of real numbers. Real number is any number that you could place on a number line. Now in Algebra 2, when you get to that point, you'll learn about imaginary numbers and complex numbers. But for now, basically we're just saying that these 3 real numbers could be any number you have ever dealt with in your entire mathematical career. So for any real numbers A, B, and C, we have 9 algebraic properties that we're going to go through. The first property is called the addition property of equality, and it's written as an if-then statement. It says if A is equal to B, then A plus C is equal to B plus C. Now what that is saying in reality is we can add any amount to both sides, and that's the key. We have to add it to both sides of any equation. That is what that is saying in words. That's the addition property. Anytime that we add a value to both sides of an equation, that is the addition property of equality. Now there are several other properties that are extremely similar to this, starting with the subtraction property. It starts off exactly the same way. If A equals B, then we are allowed to subtract whatever we want from both sides of the equation. So A minus C is equal to B minus C. We can subtract any value from both sides of an equation. Okay, we are always allowed to add and subtract whatever we want as long as we keep the equation balanced, and we should already be aware of that both from our prerequisite unit in geometry and from any algebra or pre-algebra class that we've taken beforehand. Okay, we're allowed to add, subtract whatever we want from both sides. Those are our first 2 properties, the addition property and the subtraction property. The next 2 are extremely similar. They're the multiplication property of equality and the division property of equality. They basically say the same thing. If A is equal to B, then I'm allowed to multiply both sides of that equation by any value C. In other words, A times C is equal to B times C. Okay, we can multiply both sides. That's the big key. It has to be both sides of any equation. As long as we keep it balanced, as long as whatever we do to one side, we do to the other. Now, division does have a slight caveat. It is written exactly the same way. If A is equal to B, then A divided by C is equal to B divided by C. Except, since we're not allowed to divide by 0, we have to add the small detail that C is not allowed to equal 0. Okay, so we can divide both sides of an equation by any value except by 0. Because division by 0, as we should already know, is not possible. It is undefined. So there's your first 4 properties. Again, we should be familiar with all 4 of those. We're essentially allowed to add, subtract, multiply, and divide any value that we want from both sides of an equation using the addition property, subtraction property, multiplication property, division property of equality. Okay, these next 3 properties are the ones that are the most likely to have been missed in pre-algebra. You may have missed these, so I will take my time here on these 3. They are the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. Reflexive, symmetric, and transitive are going to come up a number of times throughout the school year, so it is very important that we know what those words mean. The reflexive property says, for any real number a, A is equal to itself. In other words, A equals A. Now that seems like a really not important thing, like it's not that big of a deal. But when we actually get into geometry proofs, we're going to use this quite a bit. We'll use the reflexive property fairly often in geometry proofs. Although it does tend to be the reflexive property of congruence, not equality. So we'll get to that in a later section. But reflexive property says every number is equal to itself. The symmetric property is another one that we are definitely familiar with from pre-algebra and algebra, but we may not have known that it was called the symmetric property. What it says is that if A is equal to B, then that means we are allowed to swap the 2 sides of the equation, meaning that B is also equal to A. Okay, the property says that the left and right sides of any equation are interchangeable. We can always switch them around if we need to. Excuse me. Okay. Finally, the transitive property says that if A is equal to B and B is equal to C, that means that A is also equal to C. Okay, so that one is sort of self-explanatory. Basically, if 2 values are equal to the same value, then we can say that those values are equal to each other. Okay, so those are our reflexive, symmetric, and transitive properties of equality. We have 2 more properties to cover, and then we'll end this first video. The next one is one we should be familiar with again from pre-algebra and algebra. Depending on which class we took, we should still be familiar. That is the distributive property of equality, which says that A times the quantity B plus C, where A, B, and C are all real numbers, is equal to A times B plus A times C. We have all practiced distributing already in this course, so this should not be a surprise to us. That is what it looks like formally written out. And finally, the substitution property of equality, which we will use in a couple of different ways, one of which is to simplify steps in our proofs, says that if A is equal to B, then B can replace A in any equation, which again is a skill that we have already practiced this school year, so that should not be a surprise. So those are our 9 algebraic properties. We are going to use those to carry out what are called algebraic proofs, and we will use most of them as well in geometric proofs later in the year. So we need to be familiar with these 9 properties, as properties are one of the options that we are allowed to use in informal geometric proof. Thank you for your time. The next video will show an example of an algebraic proof and the other type of problem that we will see from 2-6.